Hello and good day. In Algebra, we're starting CO16, which is working with what are called compound inequalities. Okay, and we actually kind of foreshadowed compound inequalities back in CO13 when we started writing inequality statements for situations. Right. For example, when we said that you go to the store and you spend no more than $20, we said the inequality for that was n is less than or equal to 20. But we also said that that wasn't exactly accurate. Do you remember why we said that? That representing the situation of spending no more than $20 at a store using the inequality n, or the amount of money spent, is less than or equal to 20 is not exactly accurate. Michael? Well, you would include tax in there, right? So you wouldn't buy something that's $19.99 because then you would go over 20. So we did bring that up. That wasn't exactly why. Yeah? Right. This inequality tells us that any value less than or equal to 20 represents that given situation. That's just not true, right? Technically, -5 is a solution to that inequality, but you can't go into a store and spend -$5. Okay, it doesn't make any sense, right? Haha, that's kind of a money joke. Sense doesn't make any sense. And so, if $20 is kind of the maximum, what would the minimum be? What would the other limit to this inequality be? Caleb? Zero. Okay, and that's the spirit behind compound inequalities, is that we are talking about inequalities that have limits, okay, or more in real context. So, for example, water temperature. Tap into your science knowledge here. At what temperatures is water a liquid? At what temperatures is water a liquid? William? At exactly like 32, only 32, exactly 32? Above 32, below 32, what are we talking about here? Okay, Joe?
32, it's above 30, oh my gosh, I can't talk. Okay.
Shush.
I'm not allowed to talk. I can't talk.
Fair enough. Peter?
Greater than 32.
Okay, so it's a liquid when the temperature is greater than 32. We can't say greater than or equal to 32 because at 32 degrees, what happens? It freezes, right? It turns to a solid. Okay, boys, I need you facing me. Okay, turn yourself around so you can write the notes. Don't be talking back behind you. Okay, face forward. So if the temperature is greater than 32 degrees, water is going to be a liquid. Is that true forever? No, because there's a freezing point and there's a boiling point. Does anyone know what the boiling point is? Joey?
128.
Not 128. Will? 212. Okay. So there's another condition here, right? The temperature must be greater than 32 and the temperature must be less than 212. Yeah.
Because it hasn't turned to a gas yet.
At 212, it does start to boil, which is the steam. Okay? I mean, if you're boiling a pot of water, it doesn't just instantly vanish at 212. There's still water in it. But if you let that water boil at 212 degrees for long enough time, it will be gone. Okay? Let's not get too sciencey here. Science is not my strength, but let's just go with it. All right? So graphically, how we're going to represent this, right? We're still going to get a number line. And this time, we've got kind of two solution numbers here, two reference numbers on this line, 32 and 212. Okay. What circles are going to go above 32 and 212? James? Open, because not including 32, not including 212. And how we're going to connect these is with a line, right? This graph shows us that those temperatures greater than 32 and less than 212, water is going to be a liquid. Okay? Follow me so far? Will, question?
32, 31 with closed circle?
You couldn't do 31 with a closed circle because then that would include values like 31.5. And at 31.5, it's a solid. You also couldn't start with 33 in a closed circle, saying 33 degrees and up, because that would not include stuff like 32.2, 32.9 when it is a liquid. So we do need 32 and 212 with open circles. So the other side of this now, at what temperatures is water not a liquid? At what temperatures is it not a liquid? Peter? 212 degrees and... Okay, so exactly those 2 degrees only? Those 2 temperatures only? What if it's 214? Or 220? Or 12? James?
If it's above 212.
Okay, so if the temperature is greater than or equal to 212, right? Because at 212, it starts to boil, therefore it goes into a gas. Or what, William? All right, I put these in a certain order, and you'll see why, just a little bit here. But the temperature is got to be less than or equal to 32, or the temperature is greater than or equal to 212. All right, we can't just say 32 and 212 because there are other temperatures that exist. Okay, this graph, we're still using 32 and 212 as kind of our reference points. This time, because 32 and 212 are included, we're going to have closed circles. And from 32, we're going to the left. And from 212, we're going to the right. Okay. So is there any temperature that is not included in either of these graphs? No. We've got everything less than or equal to 32. We have between 32 and 212, and we have 212 and above. Okay. This type of statement here is called an AND statement. And the reason why it's called an AND statement is there are 2 conditions that must be met. Water is a liquid if it's greater than 32 and less than 212. Both of those things must be true. This one is called an OR statement because water is not a liquid when it's less than or equal to 32 or greater than or equal to 212. It can't be both, right? Can't be both a solid and a gas at the same time, right? It's got to be one or the other. So the difference between these is that an AND has 2 conditions, and OR it's one or the other. And then the AND statements, they're connected. Okay, the OR statements go away from each other. Isn't this fun? Who knew this existed? 8th grade did, because they did this yesterday. But you didn't, and now you do. Yeah.
Wouldn't there be a point where the water just couldn't get any colder?
And there is such a thing as absolute zero, if you heard of that. Kelvin. Again, let's not get too sciencey here. But yes, there is an absolute zero. I don't know. Mr. Olson would know more about that than me, but there we go. Okay. All right. Good so far? Okay. So here it is in kind of the verbal explanation, application of it. The algebraic inequality type stuff is down below here. It says solve each compound inequality and graph your solution. Show how you check your work. How can you tell, just by first glance, first impressions here, how can you tell whether you'll be dealing with an AND statement or an OR statement? What are the characteristics that you see here in the algebraic sense between AND and OR? Drew? Isn't that nice? Right? Yeah. The OR statements literally have the word OR in them. Right? That's fun. Okay? And then what do you notice about the 3 AND statements? Yeah.
All of the symbols are facing the same way.
Okay, the symbols are facing the same way. Versus in the OR statements, notice how we've got 1 less than, 1 greater than there, 1 less than, 1 greater than there, because they're going away from each other, right? Opposite directions. The and statements, they're both less than, okay? Peter?
They use the same variable.
You mean the and the or? The and, so the variable is between our two target numbers, okay? You can read this as -11 is less than x. And if we went back to CO13, when we wrote inequality statements two ways, what's the other way to write -11 is less than x? Who remembers? Blake?
11 is greater, -11 is greater than
No?
less than
Well, that's what we have here. That's what this says. What's the other way to, yeah. X is greater than -11, right? And then the other half of this inequality says x is less than 14. So the reason why we can write it with x in the middle like that is because when we graph this, -11 and 14 are our two limits. -11 is less than x, which is the same thing as saying x is greater than -11. Well, that means that our values are going to be going to the right of -11. X is also less than 14. That's why they connect. Okay? And the reason why we can write it as one fluid inequality, -11 is less than x is less than 14, is because that's the same thing as saying x is greater than -11. So that's why we wrote it two ways back in CO13 to hopefully kind of make that a little more, some more sense. But there we go. There's the graph of that compound inequality saying that essentially x is between -11 and 14. Okay? Let's skip over the or statement to the third one here. 18 is less than or equal to x minus 3 is less than 32. We're not ready to graph this yet because x is not by itself, right? What this is saying to us right now is that the value of x minus 3 is between 18 and 32. We want to know what the value of x needs to be to make that happen. So just like any other equation or any other inequality, we're going to be getting x by itself. How do you suppose we do that? Caleb?
You add 3 to everything except x.
Opposite operations. And in fact, you do add 3 to all three parts. You've got the middle, you've got the right, and you've got the left. Okay? They're kind of like three sides, quote unquote, sides to this, but more like three parts. Adding 3 to that middle part gets x by itself because they cancel out. That's one of these opposite operations, right? So x is alone. And then 18 plus 3 is 21. That becomes our new left limit. And 32 plus 3 is 35. That becomes our new right limit. So what this is saying is that in order for x minus 3 to be between 18 and 32, x got to be between 21 and 35. Graphing this, we've got our two reference numbers, 21 and 35. 21 gets a closed circle because it's less than or equal to. 35 gets an open circle because it's just less than. And because it's an and statement, those are going to be connected. Yeah?
So one circle can just get a closed circle, so one can be...
Yep. Yeah, what this is saying is that x can be 21 and anything greater than that up to 35, but not including 35. Okay? You do need to check your work. It does say show how you check your work here. How do you suppose we would check to see if we've done this correctly? Peter?
Plug in a value for x,
What do you want to plug in?
0.
Okay. I know I've talked before about how I love to plug in 0 here. In this case, though, I would recommend choosing a number within this range because A, the math really isn't all that difficult to do. You're just subtracting 3 from it. And especially since you're learning this for the very first time, you'd had some background in equations and inequalities before, but this being very first time, I would pick a number that's within this solution range. So pick a number. 22, okay? 22 is right here or so. It's in our solution range. If we take 22 minus 3, which is 19, is 19 between 18 and 32? Yes. So it checks out. Okay. If you had picked 0, 0 minus 3 is negative 3. It's not in between that range, which it shouldn't be because 0 is way over here, right? Okay. Questions so far? You with me? Good. All right. Let's go down to the bottom middle, the other and statement on this page. 12 is less than or equal to negative 2x plus 2, which is less than or equal to 20. What am I doing first to make this graphable? Meaning I got to get x by itself. First step, Blake. Subtract 2 from all parts. Yes. 12 minus 2 is 10, which is less than or equal to negative 2x because those 2's cancel out, which is less than or equal to 20. Nope, it's not. Less than or equal to 18. Sorry. Okay. Now what? Yeah, Adam. Divide by negative 2, which means the inequality symbols, both of them, get flipped. The same rule of dividing by that negative number that we learned about in CO16 applies here. Divide by negative 2, we get negative 5 is greater than or equal to x, which is greater than or equal to negative 9. Anybody see anything quirky about that solution statement that we have there? Yeah, Sepa?
Negative 9 is lower than negative 5.
Yeah, it's kind of backwards, isn't it? If we looked at the other ones, like negative 11 and 14, those are kind of in order, and that negative 11 is on the left side of 14 on the number line. Same thing with 18 and 32, 21, 35, they were in order. Here, we started out, looking good, 12, 20, but then it flopped. Why did it flip-flop? What did we do that you suppose would cause that to happen? Gino? Because we divided by that negative value. So we didn't do anything wrong, right? All it means is that when we graph this, we need to put it in the correct order. Negative 9 is on the left side of negative 5 on the number line. Each one gets a closed circle, and it's an and statement, so they are connecting. Okay? And if you break this inequality down into its two parts, x is greater than negative 9. That's what our graph says there, right? It's to the right of negative 9. And then negative 5 is greater than or equal to x. The other way to say that is x is less than or equal to negative 5, which our graph also shows. So it's nothing that's mathematically incorrect. It's just a quirk. And that's going to happen when you divide by that negative value because you're flipping everything around. Okay, Michael?
Why wouldn't we do, in the first step, negative 2x minus 2?
We did do that in the first step. We subtracted 2.
No, but by the negative 2x. Subtract 2 from negative 2x.
Well, that's not what the inequality states. Why are we only subtracting 2 from the constant?
Yeah.
Oh, because negative 2x and 2 aren't like terms. We can't subtract them anyway. The same reason why we don't just add negative 2x plus 2 to get 0x, right? Because the one term has an x, the other one doesn't, so they can't be combined with addition or subtraction. So when we start our opposite operations, we say, well, what's being done to x, right? We're multiplying by negative 2, and then we're adding 2. Let's undo that. So we start by subtracting 2, undoing that step, and then divide by negative 2 to get x by itself. Okay? All right. Questions on and statements? Okay, let's go to the ors. And back up to that top row. where we have x is less than 5 or x is less than 15, that one's ready and tailor-made for us to graph because x is already by itself. So we're just going to do this. X is less than 5, open circle going left, or x is greater than 15, open circle going right. And we can kind of, in our minds, verify this is an or statement because can x be both less than 5 and greater than 15 at the same time? No, it's got to be one or the other, which is what this graph shows. Okay. We go down in the second row, that first one, and we're not ready to graph those because x is not by itself. And that word or, it can kind of serve as like a divider. We're not going to solve both inequalities at once with the and statements. We're going to solve each one separately and then just graph our solutions on the same number line. So for this one, we're going to start by adding 5 to both sides there to cancel it out. So we get 2x is less than 2. Divide by 2 to get x by itself, and we get x is less than 1. It's a standard, relatively simple two-step inequality that we learned about in CO14. On the other side, things don't work out quite as cleanly, but it's still, not that bad. Subtract 1 from both sides. We get 3x is greater than 10. Divide both sides by 3 to get x by itself. And there's no reason not to leave this in fraction form, just 10/3. Okay, 10 divided by 3 doesn't work out evenly, but 10/3, that fraction, that's a perfectly legitimate value to have. Okay? And we're done. We're ready to graph. X is by itself in both of them. We have x is less than 1. So 1 with an open circle going left. Or x can be greater than 10/3. Open circle going right. Okay. Any issues, questions, comments, concerns, complaints, comments, congratulations? Yeah.
How would we check?
For this one, so to check an or statement, you could pick a value in either of your solution sets and then plug it in, because it's not going to work in both of them, right? But if we picked 0 here, which is this solution, if we plug 0 in here, 2 times 0 minus 5 is less than -3. Is -5, because that cancels out, is -5 less than -3? Yes. Okay. 0 is not going to work over here, right? But it's not supposed to. It's not both of them. It's one or the other. You could also pick a number within this range here. And what would you expect to happen if you picked a number and plugged that into either inequality? It's not going to work in either of them, right? It's not part of either solution set. So if we picked 2, which is in between there, it's not going to work in either one because it's not part of either solution set. So to check an or statement, you could either check it twice, pick a value from both solution sets and plug that value into its inequality to see if it works, or you can kind of just math hack, check it once by picking a number that's not in either solution set, and it's not going to work in either one. Okay. Anything else? Anything else? Okay, let's go over to the third one. A little bit more to do here as far as the solving is concerned, but we can handle it. We've got 2 times x plus 7 is less than 8, or 10x plus 1 is greater than 1. So just like before with the other or statement, just like before, get it? We're going to kind of divide this into two parts, okay, and solve each inequality separately. The one on the left, we're going to distribute our 2 to get 2x plus 14 is less than 8. Subtract 14 from both sides. 2x is less than -6. Divide both sides by 2. X is less than -3. Don't flip our sign because we didn't divide by a negative. We divided by positive 2. So we keep things as they are. The other one, 10x plus 1 is greater than 1. We'll start by subtracting 1. Opposite operations. We get 10x is greater than 0. And this tends to throw some people off sometimes when you get 0 on your solution side. Okay, 0 is still a number. We can still use it. Our second step here is to divide by positive 10, divide by that coefficient. We'll still do that to get x by itself. And what's 0 divided by 10? 0. So, don't be thrown off there by having that 0 on your solution side. You can still solve it. So we have x is less than negative 3 or x is greater than 0. Make our graph negative 3, 0, open circle going left, open circle going right. X can't be both less than negative 3 and greater than 0. It's one or the other. That's why it's an or statement. Okay? Yay. This is, you're starting to reach the point in algebra where if you bring your homework home and ask your folks to help you with it, some of them are going to start to not be able to help you. Like, what? Huh? I don't get this. Siblings maybe, but adults maybe not so much, depending on what career they do and which type of math they use and everything like that. But so be ready for it. Okay? Be ready for it. Anything else with this front side? Okay. On the second page, you've got more to practice here. The top row, those first 3, are set up to be and statements. The second 3 are set up to be or statements. So I'd like you to work on those 6 for homework. Kind of the same process as we did on the front side. Make sure that your number line makes sense and you're checking and, in case you run into any quirks, okay? And then the bottom section here, the daily limit on your debit card is $150. Anyone have a debit card, by the way? So you all know what they are, right? Yeah. Okay. So the daily limit, so think about what that word limit means, okay, on your debit card is $150. Write and graph an inequality showing how much you can spend in a day. Now, since we are working with compound inequalities, what should your graph look like? A compound inequality, right? So it's going to either be an and statement or an or statement, okay? If it's not, then you need to revisit and make sure you're thinking about it correctly. But your daily limit on your debit card is $150. What are the possible amounts of money that you could spend in a day? Then a unique plant only pollinates when it is less than 3 feet tall or greater than 5 feet tall. Write and graph an inequality showing the heights at which the plant pollinates. What type of statement do you think that one's going to look like? And or? Joey? What? It's or, right? Look, says right there. Okay, that's a good hint. Then the brain buster. In a dance competition, routines must be 8 minutes, 30 seconds with a standard deviation of 10 seconds. So here we see this phrase that we've heard before back in CO11, right? So absolute value stuff. But routines must be 8 minutes, 30 seconds with a standard deviation of 10 seconds. Routines that are 15 seconds longer or shorter than this range will result in a 2-point deduction. So if you're too short, 2 points off. If you're too long, two points off. Create a graph showing the times for which you would receive a 2-point deduction. Okay, that is your homework for tomorrow. You've got, oh by golly, like 8 minutes to work on it now. So if you have questions, we can go over them. But I think you are ready to practice. Final things to discuss before we sign off. Okay, folks, that is High Math.
Don't forget